All right, this one is what's called p-series, and this is another test we can use to see if something is convergent or divergent. And what this is if you have any series that is 1 over n to some power, that power will dictate whether it's convergent or divergent. And it'll be convergent if p is greater than 1. So if this is a power, anything bigger than 1, it's convergent. Divergent if p's 1 or less. Let's look at why. P equals 1 is the easiest one to see. If p equals 1, then this becomes the series of 1 over n, and we know that's the harmonic series, so that one's going to be divergent. So that's our case here where it's equal to 1. If p is something bigger than 1, then if we use the integral test, the antiderivative of that would be if you move this up to the numerator, would be negative p, add 1, put the reciprocal in front. So you'd get that. Well, that's going to end up being, if p is greater than 1, that if you put a bit number bigger than 1 in here, like 2, that result's going to be negative or less than 0. So that means that x to a negative power is going to go to 0 as we do the limit, which we know then tells us that this is going to be a convergent series. So as long as p is bigger than 1, it should converge. Convergent if p is bigger than 1. If p is less than 1, though, that means this same x value is going to be a positive number. And if you have x to some big positive number up here, as you go to infinity, that's going to keep getting bigger and bigger and bigger. So that one's going to diverge. So anytime you got a power bigger than, bigger than 1, or sorry, less than 1, then this is going to be divergent. Divergent. All right, so let's look at a couple examples. Determine whether this converges or diverges. In this case, you can simply say this is p series, and our power here is 1.3. So what we're going to say is by p series, this particular series is going to converge, and the reason would be our power here of 1.3 is greater than 1. Anytime our power is bigger than 1, then our series is going to be convergent. So our p on this one, that's our power here. Our p is 1.3. That's bigger than 1, so this would be a convergent one. All right, let's have you pause the video and try this one out on your own and see what you get. All right, hopefully you tried it here. This one you're going to probably want to rewrite or think of if you got the 5th root, that's the same as 1 over n to the 1/5 power. So our p here is 1/5. Well, we know by p series, if your power is less than 1, that's going to be divergent here. So we know by p series, this one should be divergent. 1/5 less than or equal to 1. Anytime that happens, you have a divergent series.